Hello everyone. Welcome to the first session of Database Management System. Database Management System is a subject which you get in the third semester having the code 15CS33T. So to start with, the contents for the session 1 we have as follows: introduction about the various terminologies, definitions, databases and database users, and then database basic definitions which may come across with the various relevant terms, and then the functionality along with some diagrams. Finally, we'll conclude the session with a practical example of a real-world database and some main characteristics of the database approach. Before we start the actual contents of the section, I would request all of you to please be with paper and a pen, pencil, whatever. See, you are going to get some important aspects or the points which you go to note down. If you do that, it will be really helpful at the end of the session as we come across with some of the questionnaires which will enhance your learning capabilities. So please take this into the consideration. So to start with, we have the basic definition of this database management system. Database management system, the term itself is a huge, so don't get panic. Such a 4 words, database management system. No, it is not. We make it more and more simpler and understand the basic definition term related to the database. So it comprises of 4 words as you are seeing: data, database, and finally we'll have database management system. So to start with, data. What is a data? Data, it is a very important term. Everyday life, in our daily life, we encounter so much of data. Everywhere it is data. What is data? You yourself is having so much of data. It may be a data related to your college, related to your school, hospital, university, where not. So to start with, you consider yourself as an example for the data. How you can be example? Yes, you can be. Your name is a data. I have given example like Sushant or whatever, Sumant, and a register number, some semester. All these facts I can relate them as data. So we get a definition for a data. Data is a collection of related facts and figures. So I've just quoted the definition as some name, some register number, all that can be termed as a data. Now comes database. Let us relate database to the data. So database is a collection of related data. How it is related? See, you have so many students in one section. All of them are related to third semester. So we have maintained attendance. So that itself is a third semester data. And such semesters, we have many such semesters. First semester we have, third semester we have, fifth semester we have, so on. All that data will related to the particular branch, and we call it as a database. So in general, I can quote it as a database is a collection of related data. Example, I take yourself as example, like if you take your class, your branch, your college, student database can be a best example. Now, as we have differentiated data, database, let us come across the definition database management system. We have large amount of data with us now, and we are relating that data into a database, and we need someone to manage this data and maintenance of this data. That is where we have database management system. It is a software package to facilitate the creation, maintenance of a database. So you can think of a software which will be managing your entire database. So if you can take an example, it can be MySQL, Microsoft SQL Server, or Oracle. This can be a part of your lab later on, because when you create a database, you're going to work with these. Hope you have understood data, database and database management system and also differentiated those terms. So collectively, I can term it as database management system is nothing but a mere collection of data, which is again related data. Database is a collection of related data, and we are going to maintain that data using a software package. We term it as what? Database management system. Next comes some more important terminologies related with database. Mini world. As I'm talking to you, this is just a database, is not something imaginary. It's not something I can just think of, something numeric, something alphabet. Okay, no, it is not. It is something existing in the real world. So what we have here is some part of a real world about which the data is stored is a mini world, we term it as. So in this particular DBMS subject, you have come across with this word many a times. We call it as what? Mini world. So for example, you take the hospital next door. You have some hospital database that is existing. I cannot have a fake database. I have patients who have entered. I have doctors working over there. I have many other people who are working in that hospital. So we term it as what? Hospital database. Then we have one more important term, database system. So this is very, very important. Database system is something, a DBMS software together with the data itself. So as I told you, if I have a data, I have to manage and maintain that using a package, and that is nothing but our DBMS software. So the database and the DBMS software collectively together we take it as a database system. We can also include the applications in that. So do not worry about all this, because we are going to elaborate once again with the diagram, with the examples. So as you know the basic terminologies, now you must be knowing database is having a very, very, very important in our everyday life, and it should not be some fact and figure. It should have some basic objectives. So here I am defining those basic objectives. First one, defining the data. So defining is very, very, very important. I have to define it properly. Name means I cannot define the name as it is, something, some alphabet, ABCD, 1, 2, 3, 4. No. Name should have a proper data type. It should be only characters and should have a proper structure. Constraint in the sense some condition. I can give the condition. Name, somebody says name can have only 2 characters. No. I can define the condition. Name can have at most 50 characters. Okay, at most 50 characters and not lesser than 1 or 2 characters, because I am defining the condition. Constraint is a condition where you are checking the validity of your data. You cannot have 1, 2, 3, 4 as a name. Name must be alphabet. So that is termed as constraint. So all that I am taking care with respect to what? Defining the database. Next comes the storing of a database. Here it is a process of storing on some storage medium, because as you know, without storing the database, I cannot work with it. I have to maintain it. Okay. So storage is very, very important. Then accessing. Accessing is nothing but the retrieving of a database. So that includes querying. Querying, it's very, very simple to understand what is a query. Querying for specific information. So you want something, some information. Suppose you want to check the whether something availability of some product or something like timings related to some hotel or whatever. You want to search for a particular data. What you do, the best example what I can quote, as you are all familiar with the internet, we use a search engine like Google. What we do there, we type like where will be this particular address or location, a distance from Davangere to Mysore. I want to know. What I do, I'll type a query in Google. So distance between Davangere and Mysore via road. So that is my query. Query is nothing but a question. Obviously, it will search and display the result for us. So querying is nothing but a searching or question. So where I am putting my question and accessing the specific information. So everything in a database, we call it as query. Query is nothing but selecting a specific data, okay, or information. Next comes manipulate. Manipulating is nothing but adding, deleting, updating the database. See, I am telling you, like you are studying in your college and sometime in our first semester, second, third semester, you will get transferred to some other college. So what we do, the data in our college, that is the student data in our college, we delete because he is physically transferred to some other college and the other college will add. So that is adding and deleting because we are working practically. So it is not consistent if I maintain the data who has already transferred. The student who has already transferred should not be in my register, right? So that is what we call as manipulating. So manipulating is something related to adding, deleting and also modifications or updating. Finally, sharing. Sharing is very important here because multiple users are accessing the data simultaneously. Simultaneously is nothing but concurrently. So that is very important for us. So sharing the data in real time has got a lot of importance. How? So you can just think of reservation systems. So I have to share the real data over there, real time data. Multiple users are accessing, like I'm trying to reserve a ticket to Bangalore. I'm being in my city. So take an example of train reservation or bus reservation. One more person in some other city also be trying for the reservation. So at the same time, two users should never clash. They should be taken into consideration in such a way that each one will share a valid state of database, like availability of ticket, availability of seats, all that. So data should be shared appropriately. Consistent data means valid data should match in the status. So sharing is very important as multiple users are sharing the same database. So you will come to know, again I will be quoting this example later on when we talk about the characteristics of database. So this is the time being, what we have is one line definition for the 5 objectives, that is defining, storing, retrieving, manipulating and sharing the database. You need to remember these 5 important objectives. As you have understood the objectives and what is we got an idea about what is a database system, you can visualize this diagram easily now. So what we have here, a simplified database system environment. See, it is divided into 3 parts. So if you observe there, first part is users, outer users or programmers who are trying to access the database via the application programs or queries. Then the second part where we have the DBMS software, which comprises of software and queries, programs, and those are used. And just now I have quoted you. What is a query? So query is nothing but you are asking a question. You are retrieving, using a command, you are asking a question. And that will be trying to, using that query, and we are trying to access the stored database. This is the second layer. And in the last layer, that is the bottom layer, you have the 2 important aspects there. Stored database definition and stored database itself. So there you can see one small metadata in the bracket. That's very important. Do not think it's like something okay we can eliminate. No, it's very important to know about the metadata. Metadata is something which is having the description about data itself. Just now I was telling you the definition about the data, definition of the data. I'm defining the constraint, I'm defining the data type, I'm defining the structure. All those things will be taken care by metadata. Metadata is nothing but description about the data itself, what the data should contain, how it should be stored, what is the structure. All those things will be taken care by this metadata. So whenever we get this term metadata, you need to think it is just a description about the data. So they see there the interaction is two-way, means You are asking a question, you're getting the answer. So you're asking a response, you're requesting for a data and you are getting the response. So in the last layer, you can see the two-way arrows so that the data will be sent back to the whatever the required query, that is specific data will be sent back to the user. So there are three important points you are supposed to see here. Users, okay, and the second layer is DBMS software itself, which is again divided into the software that is comprising of programs and queries, and the accessing, that is the stored data, and in the last layer we have the database itself along with the definition of it, that is the stored database definition, that is nothing but what? Metadata. It's a very simplified environment. This will give an idea about how exactly the database is stored or visualized. Okay, let me get into an example. Like hospital, just now I was quoting, is a very simple way I have put this example. I am thinking of a real environment like hospital environment where I have considered it as a mini world. I told you mini world is something existing. You have to consider it as real data, real entity existing outside. So you can think of any hospital comprising of some three important things. So some mini world entities I am considering here: doctor, patient, and a room. Like hospital have different rooms. If a patient is getting admitted, I will be allocating him the room. So three entities I am considering here. If you see this, if I have to structure this database, if I have to conceptualize, I am putting it across. Patient comprising, the structure is, description of my data is patient number, patient name. Very simplified it is. Not a real, if you go to real one, it's a huge data. Next I'll be showing you that. And then the doctor is having his own ID, physician ID I'll take it as, and then physician name. And this doctor is related to the patient. See, we are talking about related data here. So patient number, inpatient, see there, the database of patient consists of patient name and patient number. Again, the doctor database also contains the patient number. And then comes the room where particular patient is allocated. Again, it is related to what? Patient number. See, here the unique identifier which is connected to all the three entities, that is patient, doctor, room, is, you can easily identify patient number. So this is what I mean to say related data. Okay. So now if you see another example, university environment where you can think of many entities here. So previous one was a very simpler one. Now we have student, course, different sections. Okay. So you can think of a courses. Okay. And then department itself and different instructors. So instructor in general we have considered, you can think as a lecturer, lab admin, lab instructor. Many people will come in that category. So now if you see this database, it's not as simpler as which we have just discussed, hospital. It's having many fields in it. Okay, each one is having course, section, grade. So many is having the data, the real data they have stored. This is also very small data what we are showing. Such lakhs together, hundreds, thousands of records will be stored. This is just an example. You need not have to, you need to understand what is related here. Here also you find out the unique identifier, a key which is relating to all the other existing entities. Like for example, if you see the course section, so you have course name and course number. Can you see there? For course and section, course number is repeated. So course number is connecting to course and section. Again, if you come back to the prerequisite, again there is a course number. So like this, in real existing world, we have to relate the relevant data, and it can be enormous data, not just one or two tables as I have shown here. So you need to understand this is how we are going to store the data in mini world. That's a real existing world. Okay. So as you have understood those important terminologies and also tried understanding some of the important examples of it, now you can easily understand some important characteristics of database approach. So as we have listed here, each one we are supposed to discuss in detail. For the first one goes as self-describing nature of database system. Second one is insulation between programs and data abstraction, support of multiple views of a data, and finally sharing of data and multi-user transaction processing. Okay, so these are the some of the important characteristics of database approach. To start with, the first one, self-describing nature of database system. See, that's what we have to relate it back again. Just now we were discussing about the metadata. So you remember in the previous diagram I have shown you what is the metadata. Metadata is description about the data itself. Okay, so that description itself will make our database self-describing. Okay, so that's a very important characteristics of data. So what we are describing here, see there, catalog. See, we term it as a catalog which will have the description of data structure, types, constraints. I have already told. What is a constraint? Condition. Condition on some data. Like I want register number to be all the time 10 characters only. It should not be 5, it should not be 7. All the time it should be 10. First 3 numerics should be of college code. That's a condition. That's nothing but a constraint. So all that we are going to define in where? Catalog. That is nothing but the description of the data itself. We call it as a what? Metadata. See, if you have understood the previous term metadata, it is very easy for you to remember the first characteristic. Next comes the insulation between the program and data. So here comes a very beautiful feature of database. What is that beautiful feature? See here, I am going to keep the program and the data separately. So if I change the data, nothing will happen to my program. If I change the program, nothing will happen to my data. So this itself will make our database data independence. In the sense, the data is stored independently from the programs. It's a very beautiful feature. So I can modify n number of records, n number of student records, n number of addition, deletion, modification, but my program remains same. Or I can change the program itself, but my data remains same. So there is no, conflict between them. So it's a very beautiful feature and we term it as what? Data independence. Okay. The next one, what we have is data abstraction. A data model is used to hide storage details and present the user with a conceptual view of database. We term it as what? Data abstraction. So what exactly mean by data abstraction? It's a very beautiful feature again. As you know, if you understand these characteristics with some examples and you map them with your examples, definitely you are going to score very good marks in this subject. So always try to map your definition with some examples. As I told you, abstraction is something like hiding. So someone comes and asks me, what's the time now? I will certainly not open the machinery of my watch and tell, this is, see how it works. Why? Because I'm hiding the machinery inside my watch. I'm just telling them the time is 4 o'clock now. Because data hiding. Why that watch is covered with a metallic surface and all that glass is covered for both the needles and all that is security. We want to hide the essential details of it. What I'm going to show is only the conceptual. I'm going to tell you the time, but not the, I'll not be giving my watch itself, okay, you open and check how it works. So that's what? Data abstraction. Abstraction is nothing but hiding the essential details. If someone comes and asks, we give only the conceptual view of the database, not what inside, what are the storage details, what is the structures inside, we will not be giving. It's a very beautiful feature of database, that is data abstraction. Program refer to data model construct rather than the storage. How it is stored inside is not of our concern because security matters over there. So what we have here is, only the programs. We follow what the required specific data, only that will display using the abstraction, but will not be taking the consideration of entire displaying of the structure, constructs, or whatever we'll be using. Okay. And then we have the multiple views of data. Suppose I want to know only the students who have scored distinction. I don't want all the student results. So I have one view. And I want the students who have cleared all the subjects. Might not be the distinction one, but who have cleared all the subjects to attend some particular interview. So that is some other view. So this is called as taking the specific data for some particular view. That's a different view. So that is called as a support of multiple view. I can view a data with the different views, okay, which describes like what interested. I am interested only in extracting the distinction students, or I want to extract all clear students, or I want the failure percentage. I want the students who have failed in this particular subject. So that is what we are going to have with this multiple views of data. I can view a data with the different views. And finally, we have the sharing of data. That is very important aspect, as I already told you. Sharing of a data, it's related to multi-user transaction processing, where I told you the example of train reservation. I am trying to reserve from my home and some other person in the same city is trying to reserve from his or her office. Both of us reserve, ending up with the same seat in the same compartment. Will be conflict, isn't it? So what we have to do, the data should be maintained in such a way that even though the hundreds of transactions are happening at the same time, it should be happening as if it is a single transaction at that particular moment. Means if I am reserving the seat number 50, the very next microsecond, the next person is getting the seat 51, and the next one is within a microsecond 52. Otherwise, all three of us getting a same seat like 50 and getting into the train and see, I have also reserved, if I say, it may not be appropriate. So concurrency control comes into the picture. So that guarantees each transaction is correctly executed or aborted. And it's very important also. Another example what I can quote here is the ATM. So you go there, you will try to, transaction is nothing but the steps, okay. So you enter your PIN and you check balance, you try to withdraw some amount. Suppose the amount comes, fine, you get your amount. But amount will not be, you will not be getting the amount, but your account will be debited. That is, the amount is deducted from your account. Then what should happen? Because it's a real-time transaction. There should be concurrency control, that is, each transaction should be correctly executed or aborted. That is, amount should come, transaction is success. Otherwise, amount should not come and your account should not be, deducted for that amount. So that should happen. And suppose you will not get the amount, but your account is deducted for whatever you are trying to take the 500 rupees, you will not get the amount, but 500 is deducted from your account. What should happen? Very next, you will go to manager and report. So there will be a recovery subsystem which ensures that the transaction is permanently recorded in the database. Means it is been failure there, but your account should be given back the amount whatever they have deducted. So that is what recovery. So all this will come into the picture when we work with what? OLTP, that is online transaction processing, is a major part of application. See, whatever I am speaking about, it can be ATM, it can be train reservation system, air ticket reservation, or whatever existing in real time is nothing but OLTP, online transaction processing system. You will have an entire section for this later on in your syllabus. So nothing to worry about it. Time being, you have to understand this one of the feature, that is the characteristics of our database. Now, As I have come to the end of this session, so let's have some questionnaires. Hope you have understood few terminologies. So let me have some MCQs. Please take a minute, have little patience, and as I have requested, if you have a pen and paper, please write down the answer. Do not just scroll down like at the end to see. Hopefully, I'll be giving. Now, you answer this. A data is a collection of A, B, C, D. What it is? Data, facts, software, types. Write down the correct answer. Okay. And the second question, database is a collection of data, related data, data types, programs. Hope you are getting it right. Now answer. Objectives of database management system are storing and defining, retrieving the sharing the data, manipulating the data, all the above. Which are those? Quick. Okay. Fourth one, defining database means storing and defining the data, retrieving and sharing the data, manipulating the data, all the above. Answered? Right. Let's go to the next slide. Fifth one. Read it out. Retrieving database includes A. Defining database for specific information, programming the database, querying the database, manipulating the database. Which one is true? Okay. Sixth one, the information stored in the form of catalog. So many times we have used this definition, right? So which term is related to catalog? Constraint, metadata, query, data dictionary. Quick. Okay. A catalog is a description of database, description of structure, description of constraints. Which is it? Or all the above? Answer. Eighth one, important characteristic of database. Which are the important characteristics? Just now we have discussed, right? The last topic. Insulation between data and programs, data abstraction, support for multiple views of the data, all the above. Which one is true? Hope you are getting it right. Next. The last one. Modifying the data without changing the program is known as discussed. One of the feature of this is one of the characteristic, right? Program insulation, data independence, that is program data independence, program operation independence, all the above. Which is the correct answer? Okay, we are coming to the end. Data abstraction means querying the data, hiding the data, manipulating the data, repeating the data. Which is true? Okay. So all the 10 you mark it down. Okay. So you're curious to know the answers. Shall I show you the answers? Now before I show you the answer, let me take a pause and also cover, because it's important to know that these questions can be covered from the topics we have just now discussed. That is, what is database? Explain with many world example can be asked. I have given you an example. Definition we have just discussed. You have to answer. Explain the database system environment with a need diagram. Okay. List and explain the important characteristics of database. Okay. So try to answer these questions. And now it's time to show you the answers. Check it out. These are the answers for the multiple choice questionnaires we have covered for all the 10. I hope many of you would have got it, because once you understand the terminologies in this session, you can easily answer them out. Just check it out. Okay. So if you have any queries, any information you want or a feedback, please feel free to contact us. Thank you so much for your kind attention. Thank you.